we are really going to begin by looking at a binomial distribution. I think I mentioned that some in the last video that I made. But first of all, some vocabulary. A random variable is a variable which we typically denote by just putting an X, and it's going to have a single numerical value. This value is determined by chance for each outcome. So if it's not by chance, it's not random, and we're just going to look at what that outcome is. Now, outcomes, though, could be a discrete random variable or a continuous random variable, and I think we've talked about those words some before, but discrete has a collection of values that is finite or countable, and then a continuous has infinitely many values. Now, something about countable as versus finite. Finite means it's over and it's done with, and you know at the beginning. Like there's a finite number of outcomes for rolling a die. But how many times do you have to toss a coin before you get heads? Well, we don't know for sure. You just have to toss it and see. But you could count that. You could count all of the tosses until it happens. So that's countable, but it's not finite necessarily. Continuous random variable is typically comes from something that is measured, such as a body temperature or time or even height. Okay, but that means that we could decide how many decimal places out do we need this to go, how small are the pieces that we need to include. It's continuous because there's infinitely many values that we can have there. So now, what is a probability distribution then? It's a description that gives the probability for each value of this variable, and it's often in a table. It could be in a formula or a graph, but let's look at what every probability distribution is going to satisfy. It's got to have a numerical random variable x, so we can't be talking about shirt colors, and the values have to be associated with probabilities. So when you sum all of the probabilities of your outcomes, the sum has to be 1. If they don't add up to 1, you're not looking at a probability distribution. Now, if you actually sum it up, we've got a little footnote here. If you sum it up and it's really, really close to 1, but it's 0.999 or 1.001, that's going to be okay because of rounding errors. Because we round, sometimes you can end up with something slightly different, but it's got to be that close. And every single one of your probabilities, as always, has to be between 0 and 1 inclusively. So now when we toss 2 coins, if you toss 2 coins, here is your sample space, the listing of all your possible outcomes. You could get heads, heads, or the first one could be heads, the second coin tails, or the reverse of that, the first one's tails, the second one's heads, or they could both be tails. So you can see that there are 4 outcomes, okay? So if we have 4 possible outcomes, which is right here, the probabilities for the number of heads follows. What is the probability of getting 2 heads? Well, there was only 1 outcome where that happened out of the 4 possible outcomes, so it was 1 out of 4, which is 0.25. or 25%. The probability of getting 1, now what does this 1 refer to? You're flipping a coin, it's not like it's going to say 1. Remember, it says the number of heads. So what is the probability of getting 1 head? There were 2 outcomes that had 1 head and 1 tails, so that's 2 out of 4, which is 5/10 or 0.5. And then what is the probability of getting no heads? 0. Well, that means they had to all be tails. That only happened once, so 1 out of 4. And if we take those 3 numbers and we add them up, the sum of all of that is 1. So in this particular example, the number of heads is your random variable. Okay, your random variable is what you're measuring, and it's happening by chance. The sum of all the probabilities is 1. And each one of those probabilities is between 0 and 1. Now, it does say here inclusive because it is fine based on our previous slide. See this less than or equal to? That means it's fine for a probability to be 0 or a probability to be 1. It didn't happen in this particular case, but it still fits that criteria. So this example would have, then we could make a probability distribution. One of the ways that we can show this distribution is to make a histogram. And the histogram is your graph of your probability distribution. And you can see here on the left we have probability, and then on the X scale we have our outcomes. So the number of heads from 2 coins, we could get 0, 1, or 2. Those probabilities we just got on the previous page, the probability of 0 was 25% or 0.25, and you can see that these heights fit that. Okay, now you might also notice that even though this is certainly not smooth, it is symmetrical and lower on both ends, so it starts to resemble a normal distribution. A probability distribution, though, deals with a population instead of a sample. So we're looking at all of the possible outcomes. Now, when we say population, we're not looking at people necessarily. But because we look at all of the possible outcomes, it's a population. So when we deal with mean and standard deviation and variance, we're dealing with parameters because they come from the population. And so instead of using the same symbols, we have different symbols that go along with that. So the mean, the symbol for that is said mu. Some people, if you ever have to type it, like in a text message or something, a lot of people will just put mu, but you want to say it like the cat's mew. And then variance, we have variance is our standard deviation squared. We have the same things there. So if you needed to find the mean, you can take the outcome times the probability and add those up. So like you wanted to say, hey, I needed to see 0 times the probability of 0 heads plus 1 times the probability of 1 head plus, okay, 2 times the probability of 2 heads. That would calculate the mean for you. Now, there are a lot of formulas, and you may find those as you go look other places, but if you've got your TI-84, you really don't want to use most of the rest of the formulas because I'm going to be able to show you how to use your calculator to find this information. So first of all, TI-84 instructions. If you can get to your online textbook, you can find this in detail on page 203 and 204 in the textbook. If you don't know how to get to that online textbook, you can send me a message. I'd be happy to share that information with you. But to do this, and I'm going to bring up my calculator and we'll do this at the same time. So if I wanted to do a probability distribution on my calculator, what I want to do first of all is hit Stat, Edit, and I want to put that information I previously had in my list. So Stat is right here, and notice that List is that second option, but I can just hit Stat, and then option number 1 that comes up is Edit. I hit Stat, now I'm going to choose number 1, which is Edit. Then I have a list there. Now please don't delete your list. If you want to get rid of numbers in a list, go up to the top and hit Clear, and then Enter. Clear is different than delete. If you hit delete, the column is not going to be visible to you anymore. It's actually still in your calculator somewhere, but you can no longer see it. So we clear list, okay? So now, on list 1, I list the outcomes from a random variable. I could get 0 heads, 1 or 2 heads. And then in column 2, I list the associated probabilities. Now, what is the probability of getting 0? It was 0.25. What is the probability of getting 1 heads? 0.5. And then the probability that they are both heads, again, was 0.25. So now I have entered these in my list. So if you look at these instructions, I'll bring that calculator back in just a minute. But what we're going to do next is let your calculator find a lot of values for you so you don't have to use really complex formulas. We're going to find a lot of what we want under Stat, Calculate, and one variable, Statistics, and that's what the second stat needs. Okay? So Stat, Calculate, one variable, Statistics. And then I'll show that to you, but as we do that, what happens is that list 1 is the list of possible outcomes, and list 2, which is very often blank, is my is my frequency distribution or my percentages. And so if you don't have that frequency list entered, we're going to enter that by hitting second stat L2. So I'll show you that either way. So we're going to bring this back over here just so you can see it at the same time. So again, this is what I need to press, stat, and then calculate. So to get to calculate, I have to go to the right. One variable statistics is my very first option there, so I can hit enter. And mine already says list 1 and list 2, but what if it doesn't? What if you need to get this from somewhere? If you need to get an L1 or an L2, and it's the L2 you may need because the L1 I feel like will be there. But if you need to get that, that's where you're going to go to second stat L2. So second stat, and so you have this list then of the list that you can come from, and we want to choose that second one. All right, then calculate is the next thing you want to pick, so that just means I need to go down and hit enter, and I get a large list of information there, and that's what this result is. And notice it says press the down arrow to see more. Okay, so let me make this a little bit bigger so you can see it clearly. Even though this says X bar, this is my mean. The calculator doesn't know that I have put a complete population in there. As far as the calculator knows, that was just a sample. So you as the person has to know that that was a complete list. So this is mu. All right, it shows you that the sum was 1. It shows you a lot of different things. This is my then standard deviation. I can see my minimum. If I scroll on down there, I can also see Q1 and the median, Q3 and the maximum. And then there's no more arrows, so that's it. So this is a lot of that information we earlier got from a stat plot, but it's going to become a little bit more efficient for you to use your calculator in some problems. So I wanted you to see that. So again, you can find the instructions for that on page 203 and 204 in the online textbook. And these little things in blue up above here tell you what I pressed for each one of those. So backing up, why would we need that? Because it's going to ask you sometimes what the mean is and what the standard deviation is, and that's going to be a lot more efficient for you to get that mean and standard deviation than it is anything else. Okay, so again, even though I know that this is a population, my calculator doesn't know that. So my mean is the same thing as my X bar, and my standard deviation is right here at this lowercase sigma. So it's 0.7. And you'll be able to use that to determine if we have significantly low or significantly high values. Because significantly low values are generally, we're going to try to do the cutoff at plus or minus that 2 standard deviations from the mean. So if you think about a value, a particular number that is your mean, so here that's what it meant, that the mean was 1. The average number of heads that we would get from that coin toss is 1. So average being the non-statistical word, but the mean then is 1. 2 standard deviations below and 2 standard deviations above are where we kind of have the fence for determining if something is significantly low or significantly high. And we've talked about that some before. Another thing that we can look at is the range rule of thumb. Are these things significant by the range rule of thumb? The range rule of thumb can be used when determining whether or not this is significantly high or significantly low. What was that range rule of thumb? Again, that's what we are using when we're looking at plus or minus 2 standard deviations. Okay, plus or minus 2 standard deviations being significant is really our kind of range rule of thumb. So over here, when we looked at our results, and I've just got them printed here so I don't have to bring back up that calculator again, our mu was 1, and sigma, our standard deviation, was 0.7. Even if I did that to another decimal place, that's fine. You just always have to read your instructions. So if you want to know if 2 heads is significantly high, then we're wanting to go up 2 standard deviations. So that's where we would say, well, Going up 2 standard deviations then would be 1 plus 2 times 0.7, and that's where this 2.4 came from. So significantly high is going to be anything that's 2.4 or more. So 2 heads is not significantly high then. You can also identify significant values by probabilities, okay? And we can say that however many successes, so maybe in this case 2 heads among our trials is a significantly high number of successes if the probability of getting that many or more successes is 5% or less. So if the chances of it just happening is less than or equal to 5%, then we would say it's significantly high. And actually, if we're looking at the low end, we can still use that 5% and say, well, the chances of this just happening on its own is really less than 5%. And once we get into that 5%, then we're at a significant point. Now, you can actually determine other values. Sometimes they'll say a level of significance to be like 2% because they want to even be more certain. But in your textbook and in this lesson, they're going to use 5%. How did that apply? Well, what were the chances of getting 2 heads then? The chances of getting 2 heads was 25%. So that was not significantly high. The chances of getting 2 heads is 25%. So that's pretty strong. It's not less than 5. It's, you know, we're not in that 5% range. So getting 2 heads would not be significantly high then. Okay, now expected value is another statistical term, and it's going to be frustrating to you if you don't just take this definition and go with it, because actually the expected value is not going to be what any person off the street expects to happen. Okay, it has a definition, and the expected value of a random variable x is equal to the mean mu. So you can find the expected value the same way you calculated the mean, which means if you're using your calculator and using those lists, then you can easily do that because it's going to show up on that calculator as x bar. So it is not what most people expect to happen. Well, please, shall I explain that? Suppose you pay $2 for a raffle ticket, and this raffle ticket is for the chance to win a $500 gift card. There are 1,298 tickets are sold. What is the expected value? Okay, well, the person who buys the ticket, they only have 2 real expectations. They probably expect to lose, and their other thought is that they're going to win. So they're either going to lose $2 because they paid for a raffle ticket and didn't win it, or they're going to win. Now, we'd say $500, except for they paid that too, so they're going to win $498. Those are the 2 things the person themselves is thinking. But statistically speaking, you have to average that out. And so if you go into your list and you say, okay, there's 1,298 tickets sold. One of those tickets is going to win $498. And again, the reason that's $498 is because they've already spent the $2 for the raffle ticket. But the other 1,297 tickets will represent a loss of $2. So in this first one, we have the value, and in the second column, we have the frequency. So again, to get these one variable statistics, you're going to use your calculator. Just to show you one more time where to get this information, I'm going to bring the calculator over and I'll enter it again. So we go to, first of all, we want to enter the list, which even though that says that in blue, what you want to do is hit stats. Didn't hit second first, just stats, edit. Now you can clear a list that's already in there by going up and hitting clear. All right, and now what you want to do is say, well, what are the possible outcomes? Well, there is a possibility that you will win. How many possibilities are there? Just one. That's the frequency. On the other hand, if you don't win, then you've just lost $2. So that's the -2. What's the frequency of that happening? The 1,297, the rest of the tickets. Now, once you have these entered on your list, to get this one variable statistics, which will tell you what the mean is, then we're going to go to our stats and then go to the right for calculate, and it's that very first option, one variable statistics. If you have put this in here previously, it'll still be here, your list 1 and list 2. And now earlier when I did this, the list 2 represented probabilities. This time it is frequency. Your calculator is going to be able to deal with that either way. All right, so this is the screen which is clipped and onto our slides. So I'm going to get rid of my calculator again. So the expected value, once again, expected value from our definition is the mean, mu. Well, the calculator doesn't say mu, it says X bar, but that's because the calculator doesn't know I have listed a population parameters rather than just a sample. That's for you as the interpreter to know, but it does this -1.61. What that means is that the expected value on the ticket is -$1.61. That is the mu, the mean of all of the outcomes, and that's not what the average person that bought a ticket ever thought about, okay? So when it says find the expected value, you're trying to find the mean of all the possible outcomes. Right, that finishes up this lesson.